Hello everyone. Today I'm going to introduce our newly digitized dataset from the Yue and Pinghua-speaking area. Traditional dialectology originated from Europe, and dialectologists have been focusing on sounds a lot, namely segments. And in the late 20th century, um, people have been using quantitative methods, the dialectological data. But similar to traditional dialectology, it also originated mainly in Europe, and the focus has been on European languages with these methods. Although recently we've seen that people have been applying these methods on non-European languages outside Europe, such as on Japanese or on Mayan. In the world, more than half of the world's languages are tonal. However, right now there aren't too many data sets consisting of dialects of tonal languages, more than 20 dialects, and this is the main reason why we would like to digitize a data set with both tonal and segmental transcriptions. And yeah, our dataset comes from two branches of Sinitic languages, namely Yue and Pinghua. These Sinitic languages are spoken in southern China, and they're tone languages. This dataset, unlike the previous tonal datasets, they consist of 104 varieties, and each has around 130 monosyllabic words. And the domains include body parts, numerals, animals, and geographical features. And this dataset includes both segments and tone. So yeah, the data sources. Our data mainly came from dialect surveys and homonymic syllabaries, and this is what they look like originally before we digitize them. And here are the localities and their respective sources. So let's have a look at the segmental data. So we've made some modifications to the original transcriptions. This is because our data came from um, different sources, so different dialect surveys and different homonymic syllabaries, and there were more than one transcriber for these sources. So different transcribers, they've got different conventions, habits of transcribing the same sound. So this can actually impact the dialectometric analysis, which is relying on the transcriptions. This is the reason why normalization or cleaning is required before we apply quantitative methods on our data. So in terms of what we've done, we've listed 7 main procedures that we've done. And because of time, some of them should be referred to the paper because they require a more lengthy explanation. So firstly, we've compared some of the transcriptions with the existing recordings, and made changes like from 水 to 水. This is from the Guangzhou dialect. We've also removed some redundant characters found in some dialects. For example, in the Goyang dialects, yan, yan is pronounced as we've removed the I in yan. It's because this character is used to represent some kind of indication of the palatalization after the nasal, instead of actually being there. We've also removed some overly detailed transcriptions, namely diacritics, like the centralized low R as just an R without any diacritics. We've also changed some Chinese IPA symbols to standard IPA. For example, the aspiration for P is now changed from the ejective symbol, well, the symbol that's used for ejectives, into the aspiration symbol. Next, tonal data. So a lot of the existing datasets for tonal dialects consist of around 20 to 30 dialects. And our datasets, we've got 104 dialects, which are the same dialects as the segmental data because they came from the same source. And also they came from the same words as well. And this allows us to compare the segmental and tonal variation of the same area for a large number of dialects. So in terms of how tones are being transcribed in these data, they were written in Charles' 1930 tone letters, and basically they use a numerical transcription to represent the contours and pitch. So here we've got 5 different contour levels. One means the lowest pitch level, and 5 represents the highest. And with the combination of these pitch levels, we can represent different tone contours, like level tone, ma, rising tone, ma, falling tone, ma, concave tones, ma, and convex tones, ma. For dialectometry, we cannot just simply apply the numerical representation of tones, so Child's system, into any dialectometrical tools. It requires us to convert them into other meaningful tone representations in order to yield meaningful tone distances. And in our repository, we've provided 3 different conversion scripts, namely the tone to string, which can be found in this Tang's digitation, onset contour offset, and also modified onset contour offset, which is a new representation of tones, improved from the original onset contour offset from Yang and Castro, 2008. So how does this representation work? Basically, this representation requires us to transform Child's transcription of tones into 3 main components, namely the onset, the starting pitch of the tone, the contour, the shape of the tone, and the offset, the ending pitch of the tone. Let's look at an example. For the tone 1-3, so something like ma, the onset is a 1, which means it's a low tone, the lowest tone, lowest pitch. So we use an LL to represent contour 1. And it's a rising tone, so the contour is an R, is a rising tone. And lastly, the offset is a 3, which in this system is a mid contour, mid level pitch represented by the M. And in order to calculate the tone distances between different tones, just like the original proposed onset contour offset by Yang and Castro, we apply Levenstein distance on the representation, which we've just seen in the previous slide. And if we apply multidimensional scaling on all the 73 tones that we found in our data, this is what we see. The extracted dimensions, which are underlying patterns found in our tonal inventory in the data, we found that actually they do match the perceptual dimensions identified from Gando and Harshman's perceptual study of tone distances. Next, we'd like to show you our preliminary analysis of tonal variation from our data. In Chinese dialectology, very often studies are descriptive, meaning people identify correspondences between the Middle Chinese tone categories and the present-day pronunciation. The existing dialectometric studies of tonal languages are not haven't been looking at tonal variation much on its own. So sometimes tones were neglected. People have also been working with relatively small data sets, And some of the studies, they've combined segments, so they're not looking at tones on its own. And another problem Son et al. Forthcoming have identified is that the tone distant metrics, so the metrics before, like the OC or the onsets, contour offsets, or the tone to string representation, they cannot differentiate a lot of the tones in the data. And what we've done is we've applied the modified onset contour offset representation because this representation matches the perceptual cues found in previous perceptual studies, and it can differentiate 72 out of 73 tones in our data. We are applying this on our dialects to see how dialects can differ on the tonal level. And in order to calculate the tonal distances between dialects, we first calculate the Leverstein distance of the modified OCO representation of tones for each of the words in a pairwise fashion for each dialect. And then what we do is we sum the distances, the tones for the words in a pairwise comparison and divide it by the number of words compared in total. And when we look at the distances on the tonal level, tones only, between the dialects, this is what we see if we use the MDS, multidimensional scaling, on these tone distances. In general, we do see a continuum-like pattern. However, there's a clear cluster, which is circled in red on this slide, on the right. We see that this group is isolated from the rest of the dialects. And we decided to look at this cluster in more detail. Here we can on the left, this is the zoomed in view of the same plot, distance plots that we've seen on the previous slide, and on the right is the tone inventory, six of the same six dialects, which are shown on the MDS plot on the left. We can identify three groups of dialects here. The first group consists of the Daomun, Toisan, and Hoiping dialects, which share the same tone inventory. And the second group consists of Yanping, which has a merger the Yangshan and Chu tone categories in the inventory compared to the first group. And lastly, the third group can see a phonetic difference in the Yinshan tone category with 4-5 instead of 5-5 compared to the first group. And this group consists of the Jiangmen Xinhui dialects. However, what we were seeing there is that even though in the first group there are three identical inventories, on the MDS plots, we actually see that they are quite far away from each other. So only looking at the inventory doesn't tell us why that is the case. And this is where we came to the tone correspondences between the dialects from group 1, the ones that share the same inventory. And particularly, we've been looking at the Taishan and Kaiping dialects. And we see that even though their tone correspondence, their tone inventory are the same, are identical, we actually see that if we look at the correspondences, the tones do not correspond completely between the two dialects, even though their inventory are the same. This means that the lexical distribution can also be different, even though the tonemes are the same in both of the inventories. And this means that based on what we've seen with these six dialects, we've seen that tones can be phonetically different. So the first group and the third group of dialects, we can see that there's a difference between the 5-5 and the 4-5. Tones can also be tonemically different, meaning that in the second group, there's one tone fewer than the two other groups. And lastly, based on the comparison of the group 1 dialects, we can see that there's no total correspondence between the dialects, meaning that there's also lexical distributional differences. So in total, there can be at least three ways in which dialects can differ from each other. So to conclude, we've digitized a new dataset which consists of 104 Yue and Pinghua dialects, and each has around 130 monosyllabic words, and they are both tonal and segmental data for these dialects, these words. And we've also shown our new tone distance metric, which is a modification from Yang and Castro's onset contour offset representation, which is now able to differentiate 72 out of 73 tones in the dataset. Lastly, we've shown from our preliminary study that tone seems to show a dialect continuum if we just look at tones alone. However, they can differ in 3 different ways, namely tonetic, tonemic, and lexical distribution. Our data can be found on the OSF repository, which you can find using the QR code or the link here. And it contains both the data and also the tone conversion scripts, which are written in Python. And you can find my contact info here. Thank you for your attention and hope you enjoyed the presentation. Thank you.